Hello and welcome to the course of Advanced Strength of Material. So here in this course we have already studied three module. In that three module we have completed about strain energy. After that we have seen about bending equation and the pure bending, and after that we have seen about combination of direct and bending stress. Now today I am going to start a new module. That module name is principal plane and principal stress. So let's start our lecture with lecture objective. This is your 14th lecture, so let's start. So the lecture objective for this lecture is to understand about the principal stress and strain and to get the insight about the principal plane. So here we will know about principal plane and what is oblique plane and detail of the stress that is generated in the oblique plane in real life situation, that we will see in this lecture. So let's start our lecture. So in the last lecture or in the previous lecture, what we have seen, we have seen that stress were acting on a plane perpendicular to the plane, right, or parallel to the plane. Whenever it is perpendicular to the plane or the stress which is acting normal to the plane, at that time what is happening, at that time we can say that stress is tensile or compressive stress, that is called normal stress. And another type of stress that we came across, that is our shear stress. In shear stress, the line of action of the stress is in parallel to our cross section. So these two type of stress, and accordingly the strain of these two type of stress we have seen. But in real life condition, what we can see, in real life condition, whenever there is compressive load is given to a workpiece. See here, if the compressive load is given, at that time what we can see, we can see that the breaking, the breaking or failure will occur in a inclined plane. So that means the major stress will be on this inclined plane, and now this major stress, this major stress won't be is equal to normal stress, nor it will be equal to the shear stress. So what type of stress will be acting in this plane? The stress which is acting in this plane in the is the resultant stress. So that resultant stress that is acting on an inclined plane, that can be measured by using this concept of principal plane and principal stresses. So let's see about the concepts. So in your syllabus the derivation of these concepts are not there, but we will discuss the all the cases one by one, and the formulas should be remembered. So let's start. First, what is principal stress and strain? So principal stress is whenever that planes that have no shear stress are called, mainly the plane which has no shear stress is called principal plane. So that the definition of the principal plane or the concept behind the principal plane is the principal planes are those planes which does not have any shear stress. So the planes which does not have any shear stress are known as principal plane. Now principal plane, so in the principal plane, from our understanding, what we can say, there is no shear stress, that means there is only the normal stress. So in the principal plane there will be only the normal stress. So let's see in real life condition what happen. In real life condition there is nothing like this normal plane. There is no normal plane in the real life condition. Because of why? Because the load is not acting uniformly all over the body, so that's why there is oblique plane. So the in real life stresses does not act in normal direction, but they act in the inclined direction. So in the inclined direction, what will happen? See here, if the force, you can see that force are acting normal to the to your edge, like this. The force are acting normal to your edge, but it is not acting, but we have to calculate the force, we have to measure the force, or we have to know the stress along the plane FG. So this is where the importance, this is where the complexity lies, because in real life condition the main stress calculation should be needed on this FG plane. So unlikely the previous ones, what we are doing in the previous ones, we are not concerning about the internal structure or internal planes of the body, but in the real life, for stress analysis or for strength of material analysis, what we need to do, we need to obviously we obviously need to know a inclined plane, or we obviously need to create an inclined plane and analyze the force and analyze the stresses on that inclined plane. So here the normal stress, we know the normal stress value is nothing but force by area, and this axial P is the axial force and area is the area. Now the normal stress, so normal stress means the normal stress of this FG plane. So that means if this is the inclined plane, then this will be your normal stress sigma n. This normal stress value will be, see here, this is theta value. So accordingly this is your tangential value sigma t. So theta means, so say here, 1 second. So see here, this is your direction of P. Now this is theta value, so and this is 90 degree, so this is 90 minus theta. This is your direction of sigma normal, and this is along this FG line, this is sigma tangential. Now see, if this is 90 minus theta, this angle is 90 degree minus theta, and this is 90, this is 90, total this angle is also 90. So this angle will be how much? This angle will be, this is 90, this is 90 minus theta, so this angle will be theta, and this angle is 90, so this is theta, this is sigma, so this angle is sigma cos theta. Now sigma cos theta, this is your sigma cos theta. So this value, sigma n value, is given here, that sigma n value is sigma cos square theta, and sigma tangential value is sigma by 2 sin 2 theta. This is, these two values are for single load. So this type of equation, this is the stresses on this oblique plane, this is the stresses on this oblique plane FG. Now we will see some cases. First, when the member is subjected to direct stress only, at that time what we can see, this type of formula, sigma n and sigma t value will be like this. And when the member is subjected to direct stress in two mutually perpendicular plane, that we will see later on, and the member is subjected to only simple shear stress, and the member is subjected to direct stress in two mutually perpendicular directions along with simple shear stress. So all of these four cases can occur in the real life condition. But most importantly, what we need to learn about the member, the fourth one, that is written in red letter here. So that is member which is subjected to direct stress in two mutually perpendicular direction, and the simple shear stress. So let's see about so the sigma n value will be sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta plus tau sin 2 theta. That will be your sigma n value. And sigma t value will be sigma 1 minus sigma 2 by 2 sin 2 theta minus tau cos 2 theta, where sigma 1 and sigma 2 is the principal stresses in two mutually perpendicular axis or two mutually perpendicular direction, and tau is the simple shear stress. Now we have to find out the position of principal plane. So for finding out the position of the principal plane, what we need to do, from the definition of the principal plane, what we know the principal plane is that plane where the shear stress is 0. So that means the tangential value of the tangential value will be 0. So sigma t will be 0. That would give us sigma 1 minus sigma 2 by 2 sin 2 theta minus tau cos 2 theta is equal to 0. That gives us tan 2 theta is equal to 2t 2 tau by sigma 1 minus sigma 2. Now now from the Pythagoras theorem, we can find out that if this is theta, then and this is so then tan 2 theta means 2 tau by sigma 1 minus sigma 2. So this is 2 theta value, this is 2 theta, then this will be the 2 tau and this will be sigma 1 minus sigma 2, and accordingly we can find out the value of sin 2 theta and value of cos 2 theta. So position of the principal plane will be where tan 2 theta at theta is equal to tan inverse tau minus tan inverse tau 2 tau by 1 minus 1 sigma 1 minus sigma 2. So next, so according to that, we can find out that major principal stress value will be sigma 1 plus sigma 2 by 2 plus root over of sigma 1 minus sigma 2 by 2 whole square plus tau square, and minor principal stress will be sigma 1 minus sigma 2 by 2 minus root over of sigma 1 minus sigma 2 by 2 whole square plus tau square. Now the maximum shear stress, for knowing the plane where the shear stress will be maximum, so maximum shear stress value should be found out. The maximum shear stress value can be found out by derivation. So from derivation we know the derivation for maximum value, the derivation of that the differentiation of that quantity should be 0. If the differentiation value is 0, that means that value will be maximum at that position of theta. So d by d theta sigma t is equal to 0. That gives us d by d theta sigma 1 minus sigma 2 by 2 sin 2 theta minus tau cos 2 theta is equal to 0. That gives us tan 2 theta is equal to sigma 1 minus sigma 2 by 2 tau. So that would give us 2 tau. So if we put the value of tan 2 theta like sigma 1 minus sigma 2 by 2t in the equation of sigma t, and the value of sin 2 theta and cos 2 theta accordingly, at that time what we can get the tau max value as half of root over sigma 1 minus sigma 2 whole square plus 4 tau square whole root of 4 tau square. This will be the value, this will be the value. All of these values are only these values are important for you, because the derivation are not in your the derivations are not in your syllabus. Now so what so we have discussed till now, we have discussed about the member which is subjected to direct stress in two mutually perpendicular direction along with the simple shear stress. Now another three cases are there, so that we will know. So first, whenever the member is subjected to one direct stress in one direction, so whenever there is direct stress in one direction, so the general formula first, the general formula is nothing but sigma n is equal to sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta plus tau sin 2 theta. That would be the value of sigma n, and sigma t or tangential force tangential stress value will be sigma 1 minus sigma 2 by 2 sin 2 theta minus tau cos 2 theta. So now in one direction, this is saying that stress in one direction and no shear stress, that means sigma 2 value here, sigma 2 value will be 0, sigma 2 value will be 0, this sigma 2 values will be 0, this sigma 2 value will be 0, and as there is no shear stress, so the value of sigma value of tau value is also will be 0, so tau value is also 0. Here also tau value is 0. So from here, from first equation or equation of sigma n, what we can get? We can get sigma 1 by 2 plus sigma 1 by 2 cos theta. So if we take common that sigma 1 by 2, then what we can get? 1 plus 2 cos 1 plus cos 2 theta. So 1 plus cos 2 theta will be nothing but sigma 1 cos square theta, so or 2 cos square theta. So the value will be sigma 1 cos square theta, and sigma t value, what will be the sigma t value? The sigma t value will be sigma 1 by 2 sin 2 theta. So that would be the value of sigma t, this sigma 1 by 2 sin 2 theta. So this is how we get the value the values for the member subjected to direct stress in one plane. Now if we have to calculate the value of the member, the value of normal and direct stress, the value of normal. So for the member subject, for when the member is subjected to direct stress in two mutually perpendicular plane, at that time both the value sigma 1 and sigma 2 will be there, and if there is no shear stress, that means tau value will be 0. So this tau value will be 0. Here also the tau value will be 0. So whenever this tau value will be 0, the sigma n and sigma t value will be like this, and this can be easily remembered, and this can be easily used in the problem. Next we will see about the case where only the simple shear stress will be there. So whenever there is only simple shear stress, what we can see, we can say that sigma 1 and sigma 2 both this value will be 0. So sigma 1 value and sigma 2 value, both this value will be 0. So that means the sigma n on normal stress will be tau sin 2 theta, and the tangential stress here, this complete value will be 0. So there sigma t value will only be minus tau cos 2 theta. So these are the values. So hope you understand, and if you have any problem, see here the main thing you have to remember this, you have to remember these two formula, you have to remember these two formula. If you can put for other case, just put for other case what will be done here, only sigma 1 will be there, so sigma 2 and tau, sigma 2 and tau, this will be 0. Here in this case, tau will be 0. For second case, tau will be 0. For third case, the sigma 1 and sigma 2, both the values will be 0. So that's it. And another thing, the position, about the position, this will be the position, this is the position of your principal plane, this is the position of principal plane, that is tan 2 theta is equal to 2 tau sigma 1 minus sigma 2. And the position of maximum shear plane, position that we can find here, the maximum shear plane position will be is tan 2 theta is equal to sigma 1 minus sigma 2 by 2t, that is completely reciprocal. Okay, the position of the maximum shear stress is completely reciprocal of the position of the maximum position of the principal plane, that means position of the zero shear stress. And the major and minor principal stresses, the value of major and minor principal stresses, these two value, these values should be remembered. So here no expression, no derivation is needed, only this expression should be remembered very clearly. So hope you understand this lecture, and if you have any problem you may ask in the live class. Thank you.